Okay. So today's the review class. I'm now trying to cover all the problems. But first of all, let's do the following problem. The region, find the centroid, right, of the region bounded by y equals x squared and x equals y squared. Okay. So step one, have to draw the graph. Okay, have to draw the graph. Y equals x squared is this part. X equals y squared is this part. Okay, so this is the region we're talking about. So the center, I'm pretty sure I even can tell the answer, because by symmetry, right? The center must be the center of the square. So the answer will be like this particular problem. By the symmetry, the center is x bar y bar is going to be, I'm pretty sure it's going to be 1/2 and 1/2. Okay, yeah, and this is a vertex. We have, this is a intersection point. How do you find the intersection point? Y equals x squared, x equals y squared. So in order to find the intersection point, you can y equals x squared, x equals y squared, so square. So you get a y equals y to the fourth power, and then y to the fourth power minus y equals 0, and you get y, right? And then the solution is y equals 0, and the y equals 1. That's no other solution. So when y equals 0, x is 0. When y equals 1, x equals 1. So you got two intersection points. The next step is to write down the formula for the x bar and the y bar. So x bar is going to be integral of the function from 0 to 1, because you're going to use vertical lines to set up the integrals, right? So it's going to be x, the top function, the bottom function. The bottom function is, I think it's y equals square of x. The top function is y equals x squared, right? No, the bottom function is y equals x squared. The top one is y equals square of x. So the difference should be like this, okay? This is the integral, and then here's a. What is a? A is just the integral of square of x minus x squared, and the dx. It's from 0 to 1. That's the area of that region. Okay, area of that region is going to be the integral of the difference of these two functions. And y bar is going to be a. Its integral from 1/2 is half from 0 to 1. It's half of square of x minus x squared and square. Yeah, this is a given. The f squared minus f squared minus g squared. Okay, this is a square of two, the difference of the squares of two functions. Okay, so this is section 8.3, and if you don't understand how to get this formula, just memorize the formula. Okay, the second one I didn't even derive I didn't show you how to get the formulas. But this, this is a f squared minus g squared. Okay, so you write down this part first, then you evaluate the integral. Okay, evaluate the integral, and then double check whether your answer is correct. And look at the picture. Does it make sense? You know, if you find a x bar, y bar, and you plot to the point, it's all sides of the region, then definitely it's wrong. And go back to double check your work, okay? So I'm not going to go through the details here. I'm going to go over for the test. I posted 3 tests there, example 1, example 2, example 3. Version 1, actually version 1 should be, version 2 should be version 1, okay? And version 3, I marked it version 3. is actually the version 2 with a switcher. And then I only give the solutions to the third one. Right, where's my test? Yeah, these are the questions. Oh, it's here. Right, so so there are 3 tests there, and how do you prepare for the test? You probably just print out the third version because I already provided a solution. You do it by yourself, and you grade it by yourself. Okay, that's the first thing. Then you see the gap, how many points you missed. Okay, you can grade it by yourself. Look at my answer key. Okay, and then if you find out you get 100% correct, then don't need to waste time to prepare for the test. Okay, and otherwise, look at the second version. Okay, the first one I'm going to today just go through it, and then and do more exercise, go over all the quiz problems and the homework problems. That's all you need to do. Okay, if you have extra time. So this is a review for test 1. No. The first problem I want to discuss is you are given the function 1 plus 2x plus sine x. Right? I want you to find out the derivative of the inverse function at 1. How do you solve the problem? Step 1, write down the formula. Okay? Write down the formula you are going to use. You are not able to find the inverse function. So this is a formula. Clearly, you have to find the value of the inverse function at 1. And you cannot find the formula, the inverse function. But if you look at that, f of 0 is 1, right? So that implies it's going to be 0, right? Yeah, the inverse exists. Don't worry about that. The inverse exists. You don't need to prove it. Okay. The next is just find the derivative of the function. It's going to be 2 plus cosine x. Why the inverse exists? Because clearly this function is always greater than or equal to 1. It's positive. The function is increasing. So that's why inverse exists. That's all you needed to know. Okay. Then you plug them into the formula. You will get 2 plus cosine f, the inverse, it's going to be 0, right? So it's going to be 1/3. Okay. Okay. So it's f. Yeah, this is actually going to be f prime 0. Right? F prime 0. So f prime 0 is going to be this. It's going to be 3. So that's it. We solve this problem. The second one is to evaluate integral of hyperbolic x times hyperbolic sine x. Definitely there will be integral using integration by parts, but this is one of example. Right? You see there's x there. Hyperbolic sine x is a very nice function. It's not like a natural log of x. If it's natural log of x, this is idea would be quite different between those 2 examples. Okay, this one you are going to differentiate natural log of x to get rid of that. And hyperbolic sine x is nice because you know antiderivative of hyperbolic sine x, but you don't know the antiderivative of natural log of x. Okay, so you have to, the different ideas. So what we do is we are going to differentiate x to get rid of x. Here we are going to differentiate natural log x to get rid of natural log x. It's totally different ideas. So this will be dv, that will be u. Okay. So if this is a dv, what is a v? V is a hyperbolic of a cosine x. As there's no negative sign there. It's not like a sine. Right? The derivative of hyperbolic cosine x is going to be hyperbolic sine x. Right? So that's uv minus v du. uv, u is x, v is hyperbolic cosine x, minus and the dx. Okay? Then the antiderivative hyperbolic cosine x will be sine x and the plus constant. That, right? But for the natural x times nature of x, I'm not going to do this, but I hope you can, yeah, you can figure it out. Okay? So that's my question. And if you don't know how to do it, then you can ask the tutor. But, so my next problem is to find the exact length of the curve. So when I was of the curve, okay. So you can, that means you can always evaluate integrals. So if you end up with some strange function, something's wrong with that. So you have to double check your computation. Okay. So here the graph, the curve is given by this function x is between 1 and 2. Right? Step 1, give me the formula. Okay. So the length is going to be integral of ds. Right? But you have to change to x variable. So 1 plus dy over dx squared and the dx. Okay? X is between 1 and 2. So this is what I want to see first before you do any computation. Don't just go ahead, to find the derivatives and you stop there. Okay? Even without giving any integrals there. Then you move on to the next problem because you cannot figure it out. Then you cannot get any credits. Why? Because you did not tell me what I'm doing. I'm asking to find the length. Now you find the derivative. Right? Of course, this is a part of the correct solution, but you did not tell me this is part of the solution either. Right? So it's hard to argue with me to get any partial credit. But if you write down this, it immediately tells me you know how to solve the problem. Okay? Just incapable to evaluate integral or you made any computation mistakes. Okay? Then you find the derivative. Okay? Then that will be x cubed over 4 and no, over 2. Okay? Okay? Then the product of those two multiplied the product of those two, that is going to be no, it's not product, just derivative second part, which is going to be negative half of x. I'm going to use this notation. Okay, is this notation? Yes. Okay. Just differentiate that. Yeah, you see, it's a quarter times x to the negative 2. When you differentiate that, you get negative 2 over 4. That's going to be negative 2. All right, so 1 plus dy over dx squared is 1 plus half of x cubed minus half of a negative x cubed. And the square. All right, so you will get 1 plus square it. You don't need square it out. Multiply by negative 2 times the product of those 2. Actually will be 2 over 4, so still negative 1/2. Okay. Then this 2 give you change the sign, just change the sign from negative 2 to positive 2. So there's no bigger difference just from negative half 2 to positive half 2. So you just, when you can come, and you can go back. Right? 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 Because if there's a negative sign, you get a negative sign here, but now it becomes positive sign, so it just changes to the positive sign. So this is a square. So the length is going to be integral from 0, from 0, no, not from 0, from 1 to 2 of a square root of this. So just half of it. And the dx. Right? Square root of this is, you just get rid of the square, then you get this part. Then you find the antiderivative of the function. Antiderivative of the function is x to the 4th, 8. And I think I'm going to get this. Okay. Okay. So find the derivative, double check, find the derivative is going to be positive 2 over 4. And the cancelled, yeah, this is a. Okay, so you will get 2 to the 4th power. Here's 2 to the negative 2 minus. Okay, so this is answer. Okay, you can simplify a little bit. You get fractions. The next problem, evaluate the integral. Here, sine x, 1 plus cosine square x dx. And this one, you have to use the substitution. Do not always apply the integration of parts to all the problems. Okay, I see that some things only know one method and applying the same method to all the problems, then it doesn't work. Okay, so substitution works. It's going to be, let u to be cosine x, then du equals negative sine x dx. Okay, so the integral becomes 1 plus u squared, and sine x dx is going to be negative du. So that will be negative not u squared, u just, and plus 1/3 u cubed, and plus constant. Okay, so you replace u by cosine x. Okay, then you solve the problem. Okay. If you use a substitution, just make it more. If you use the integral by parts, just make it more complicated. Substitution is always very powerful tool. Okay, such as like this one is also substitution. Okay, right. You can use a trigonometric substitution, but that's not the best idea. Guys, the best idea is just let u to be 1 plus x squared. Right? Then du equals 2x dx. Okay? So the integral here is going to be square root of u. X times dx is half of du. Okay, let's express it in the as a power function. Then antiderivative of this, and I think it's 2 times u to the 1/2. When you differentiate, you get u to the negative 1/2. And that's it. And the plus constant. What is u is which is going to be 1 plus x squared to the 1/2 plus constant. I think for this test, I shouldn't put the same problem, similar problem using substitution. Try different methods. Yeah, I should use a simple trigonometric substitutions for some problems. Okay. And definitely there will be problems like that. X plus 3 dx. Okay. So the denominator is a polynomial degree 2. The numerator is just 3x. So degree of the numerator is smaller than the degree of the denominator. So you can always determine this 2. Okay. Okay, so it can be expressed in these 2 forms, and you determine the coefficients. Okay, combine them, you get the same denominator, and here's x plus 3, here's b is x minus 2. So compare coefficients to coefficients, a plus b equals 3. 3a minus 2b equals 0. All right, to solve this, I'm going to multiply the first equation by 2. Okay, then I add it to the second equation. I get 5a equals 6, so a is going to be 6 over 5. Then b is going to be 3 minus 8, so 3 minus 6 over 5. 15 minus 6, I think it's 9 over 5, yes. Okay, so you get those 2 coefficients, then the integral of this function, don't forget the dx here, is going to be the integral of a. A is 5 over 6, right? Yeah, let's leave it a here. Why I do that? Because it takes more time to determine the values a and b. So it's better to evaluate the integral first before you even find a and b. Okay, so you know the function can be decomposed to the sum of those 2 functions, and then you just evaluate the integral. Okay, you can determine the coefficients later. So it's a natural log of absolute value of 2 plus b natural log of absolute value of x plus 3. Okay, then you try to find a and b. If you don't have a time, just leave it like that. Okay, so it's going to be a is going to be 6 over 5. B is going to be 9 over 5. Okay. All right, so this is a partial, just find the derivative y with respect to x. It's this composite of 2 functions. So first you have to write down as a derivative y with respect to with respect to x is just copy this function, then you find the derivative of the power, right? Right. Then you write down 2x plus 2 of x. That's it. So I think everybody should get points on it. Right. I feel very sorry if you still messed up like this problems. Very, very straightforward. Just apply the chain rule. Right. You must learn how to find the derivatives in this course. Right. So easily give it 10 points here. You don't need to think, just differentiate. Right. The next one is challenging. Not everybody can do that. They find so there's the guy who wrote on this. Can you erase it? Find the exact area of the surface. Yeah, this is a difficult part. I have to say that only half of the students are able to get the right answer in general. So you spend more time. If you prepare for the test, do all the problems, not just homework problem, in that section until you never make mistakes. Okay? Yeah. So this is about the x-axis. So this is a problem will make you different from other students. I just kidding. But this is the way, yeah. If you want to get A, if you instead cannot have struggling with this problem, you're not able to get A. Yeah, because 10 points, it may immediately make a big change. Okay, so you have to sketch the graph first. This is the x-axis, y-axis, right? Now, if you understand how do we set up the formulas, then yeah, then you get the most of the credits, right? So x equals 1 plus 2 y squared. This is parabola. Vertex is at 1, right? And opens to the right. And the y is between 2 and 1 and 2. So it's only that piece. Okay, only that piece, right? And then this is a notation about the x-axis. Got it? So first of all, identify the original piece. That is a piece. Already, we use that piece to find to generate the surface. Okay, so I'm going to use this piece. Write down the surface area. Okay, surface area is going to be A is going to be D. Okay, 2 pi dr. Okay. 2 pi ds. S is the arc length. S is the arc length of that curve, original curve. So you have, this is the first thing you have to write down. Okay, 2 pi is. Then you figured out which variable you want to use. You can use any of the variables. Okay, so if you use this is a point x and y, no matter which variable you're going to use, r is that r, no choice. So r equals the y value of the point. The y value is y value, right? If you want to express in terms of x value, it would be x minus 1 divided by 2 and the square root of that. Right? You can solve for y from the x and y are related by the above equation. X equals 1 plus 2y squared. Right? Then you have to decide which value we're going to use, right? And because that curve, x equals 1 plus y squared, and the y is going to be square root of x minus 1 divided by 2. Either way, right? For that piece. And here's the y is between 1 and 2. And let's figure out the domain for the x variable. For the x variable, when the y equals 1, x is going to be 3. When y equals 2, 2 squared is 4. 4 times 2, 8. 8 plus 1 is going to be 9. Okay? X is between 3 and 9. So the same curve is described by 2 equations. All right. So ds, you have many choices. You can choose this. You can also choose this. Depends on which variable you're going to use, right? Okay. So let's write down, set up an integral. I'm not going to evaluate, but this is a 3 integrals. Okay. So area, if you use the x variable, it's going to be from 3 to 9, right? Then it's dy over dx. So how can I find dy over dx? Sorry, it's 2 pi r there. I forgot 2 pi r. Right? 2 pi r. R should be expressed in terms of x. Right? And here's 1 plus dy over dx, the antiderivative of, I think this is a constant taken out, and 2 square of x minus 1. I think this is a derivative. Yes, square x. Yes. Okay, so this is a integral. After simplifying, it's not too bad. You can get yes. So yeah, you can simplify and you get square root of some linear function. It's easy to evaluate this integral. All you have to do is, yeah, let me simplify a little bit, okay? And multiply this out. This is gonna be 8. Here's x minus 1, right? Then you multiply this out. Okay? And you move this to inside, half of x minus 1, and plus 1 over 16. Okay, this is a linear function inside, so then use a substitution, linear substitution, and you can call this one as u, okay? Then it's easy, okay? So I stop here. I'm not going to do this. So the next one is the integral from, I think of y is from 1 to 2, right? Y is from 1 to 2, and this time it's using y variable is better. 2 pi is y. Then you differentiate x was 2y, so it's going to be 4y squared plus 1 dy. Okay, this is much better. Okay, then here you have to use a substitution. 4y squared plus 1, let this to be u. Okay, so this is the 2 integrals. Doesn't matter which one you use, but you make sure you should understand what is R. Okay, you have to draw the picture. Without the picture, it's an incomplete solution. Incomplete, you cannot get 4 credits. Okay, yeah, you have to give me a complete solution, including graph and the original integral of for the surface area before you simplify. You have to tell me what is R, what is ds in the formula. Okay. This is already problem number 9, right? Yeah, this is a good, yeah, this is a very good problem. Okay. So this is a problem making you whether you can get A or not. Yeah. So if you want to set up, yeah, for this one, let me finish. We have enough time. So I'm going to finish the computation here. So this is going to be from 1 to 2 pi y and square root 16, right? Y squared plus 1 dy. So I let u to be 16, y squared plus 1, right? And du equals 32y dy, okay? And so the integral becomes when y equals 1, the u variable is 17. When y equals 2, 16 plus times 4 is 64. 64 plus 65. 2 pi. And yeah, y it's going to be divided by 32. And the u to the 1/2 du. Okay. You will end up with a pretty strange numbers, okay? It's not a, so it's going to be pi, yeah, 2 pi over 32 and 2 over 3, and u to the 3 over 2. Uh, 32 divided by 4, 8. 8 multiplied by 3, 24. Right. So it's going to be 65 to the 3 over 2 minus 17 to the 3 over 2. So that is answer. Okay, it's pretty strange number. But more likely I can end up with a number like that. Okay, but we're still able to evaluate the integral. So the last problem is back to the first problem. Okay, I discussed for the centroid. Okay, so find the centroid of the region. This is a problem simpler than the one we discussed. Okay, find the centroid bounded by step 1. You draw the graph. Here's the 4. That's the region. Okay. Now, if I change y equals 0 to y equals 1, that'd be a different region, because this is a region. Okay. Right. So, step 1, you write down all the integrals, okay, before you do them. So the center will be here, x bar, y bar. Okay. So x bar is going to be the integral. This is just graph a region under the graph. So it's going to be a over the integral from 0 to 4, just x times the function, right? And the y bar is going to be a half of the f squared. And here a is going to be the area from 0 to 4 and the square x dx. So if you write down all the formulas, you already get more than 50% of credits. So you should learn how to express it clearly, okay? I'm not surprised when I look at the homework done by the 5th grade kids, and there's still many of them don't know how to express it clearly, okay? They just hear the answer, I don't want to see the answer, can you show me the work? It's harder to explain. I say, how much I needed to show? This is the first question I ask him. Well, this is a guideline. When you finish your homework, and here's the original problem, here's the answer, solution. You give to your classmate, can he understand what they're doing? Readable or not, right? If it's readable, then it's enough. If they keep asking, what is this, what is that, then that's not enough because you didn't clearly express your ideas. The same here, okay? So, if you write like this, first thing you tell me, you draw the picture. When I see the picture, I'm very happy. Okay, you get the ideas. Okay? And you write the 3 formulas, and those are the formulas for the centroid. The next step is just to evaluate integrals. If you know how to evaluate integrals, then you can do that. It's not the main purpose for this problem, right? So evaluate the integral, and then area is going to be, at the end, you still have to go back to check whether this makes sense as answers, okay? So the integral, the antiderivative square of x is going to be 2 over 3 x to the 3 over 2, okay? Yes. So that will be 8. 8 times 2, 16. So 16 over 3. That is the area. I think it makes sense. The area should be larger than the area of the triangle. What do you think? The area of the triangle is going to be, the area of the triangle, the height here is 2 and 4 and 2. So the area of this triangle will be 4 times 2 divided by 2, so it should be 4. but this number is larger than 4 because it's larger than 5. Yeah, okay. So double check that. Then the integral from 0 to 4x squared x dx. Okay, and then the antiderivative is going to be finally, I get 2 over 5 x to the 5 over 2. Okay. I will get 4 is 2 squared. That's a 2 squared squared, so 2 to the 5th here. Okay, so that's be 2 to the 6 over 5. Maybe it's better expressed in this way. Okay. Okay. And the integral half of from 0 to 4 square x squared, it's going to be linear function. Okay. So it will be 1/2 x squared. It's 1 over 4 and 4 squared. So the answer is 4. Okay. So now let's find the x bar. X bar is a ratio of this, and the other number a is going to be 16 over 3. 16 is 2 to the 4th power. So my so here that would be 3 over 5 and 2 squared, which is 12 over 5, slightly larger than 2, right? And the y bar is going to be it will be 3 over 4. Okay, it's less than 1. This is greater than 2. Does it make sense? I think so. Look at the picture. Right? And here's 4 and the 2. And here's 4, right? So more area is on the right-hand side. That's why the center must be greater than 2. X bar greater than 2. And the more areas below the line in the middle. So this must be less than 1. This is 1. So somewhere here. Right? So just match with the picture. So no computation mistakes, I believe that. Okay? So that's all about the review. Okay, we're going to take a quiz.